Okay, now in this video what I'll be doing is I'll be looking at differentiation from first principles. Differentiation from first principles can become very tedious as a component, so only for a few of the workings I will actually focus on writing out um, the formula. I'll just focus primarily on just solving the problems. So where do I start? Alright, so writing out the formula, f prime x. Alright, I know Sarah said he wanted everything to be in dy dx, so let me just see here. Yeah, I could do it in dy dx. Right now the formula. Okay, just turn this on. So dy upon dx is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Alright, so I'm not going to go into details about that. Alright, so generally the main thing to look at is this component here. At some point when you actually solve your problem out, you'll need to substitute h, or substitute for h the value of 0, and this will allow for you to actually have your answers. However, looking at the power rule, it's easier for you to actually make use of the power rule to know what your answer is going to be like before you actually solve. So let's get into just one example here. So it's f of x is equal to 3x. So what I would always do is, before I go on to the first principles, I will just say what dy dx is using the power rule. This here would give me the answer of 3. So using this information here now, I promise I'll write the formula for just maybe the 1 limit of h as it approaches 0 of f of x plus h minus f of x all divided by h. Now, for those that actually attended the class, you'd notice that there is always some cancellations, and it always would happen based on what your y value is. I'll break that down as I go through the problem. So I said dy dx, so let me just focus on dy dx. Now, of course, there would be some reason why Sir insists on us making use of the change. You might have the change in x or dy dx, so I'll stick with that as I work through these problems. So dy upon dx, limit as h approaches 0. So 3, wherever I see x, now I'm going to put x plus h, negative sign, and f of x is 3x. So I'll say this right now, always use brackets for that part. It'll be very helpful in ensuring that you don't mess up on your signs. Alright, so I'm just going to stick right in the limit at this point. So the limit as h approaches 0, and what I have here is 3 times x, which is 3x, plus 3h minus 3x, all divided by h. You'll notice that positive cancels out the negative, which is going to leave me with the limit as h approaches 0 of 3h over h. And looking here, the h is cancelled out, which means that my answer, or dy dx, for this answer is 3, just as identified earlier on. The next one is 5x squared minus 4. So here now we have f of x is equal to 5x squared minus 4. Alright, is minus 4 just minus 4? here minus 4. Alright, so we automatically know that the minus 4 after we find the derivative is going to give me 0. So let me just jump into what I said earlier on. I do my product, my normal differentiation using the product. 2, 5, 10, x, and that's going to be 0. So my answer that I should have is that. So dy upon dx, limit as h approaches 0. I'm not going to write back the formula for this one. So I put 5x plus h squared. So again, wherever the x is, you're writing x plus h, and since it's the power of 2, you're going to put it squared. Make sure you put back this minus 4. It's important. Now, like I outlined earlier on, you put back the negative sign. And what is f of x? It's 5x squared minus 4. Close my bracket. And this is all being divided by h. Alright, so I'm just going to say the limit h approaches 0 is going to be 5. I'm just going to open this bracket out here. Minus 4 minus 5x squared plus 4. So you see why you have to pay attention to this here, because this minus 4 is going to be cancelled by this positive 4. Now, this here is something that you're almost going to always encounter when it comes to first principles. The power is always going to be greater than, for x is going to be greater than 1. Now, when it's x plus h squared, your result is x squared plus 2. I don't know that sound, but I'll write xh. I probably will change it later on. Plus h squared, which is all being divided by h. Now, I know some persons would be confused based on the algebra concepts. Let me just work this here out quickly. So we'd have this, we'd have this, then this, to this. So we have x times x, which is x squared, plus xh plus xh, this is for that, plus h squared. Alright, I should write it the way I should write it. X squared plus 2hx plus h squared, since that's what most persons are comfortable with. So what I have here is what I have in my bracket up here. Do I have space? I don't. So I'll have to write it back. So writing this back once more. Limit h as it approaches 0 of 5 open bracket x squared plus 2hx plus h squared minus 4, and that is going to be minus 5x squared plus 4 minus 5x squared plus 4. Use my square bracket, put h at the bottom. Now when you are here, again, algebra, your expansion is going to be very, very important. So limit h approaches 0 of 5x squared plus 10hx plus 5h squared minus 4 minus 5x squared plus 4. This is all being divided by h. So this 4 will cancel this 4. Minus 5x squared would take that 5x squared. Leaving me here now. Limit as h approaches 0 of 10hx plus 5h squared, all divided by h. Now, some persons may have a little bit of a different opinion on actually solving this part here, but I will factorize how you should factorize. So limit as h approaches 0. So I'm going to factor the numerator. So I have 10hx and 5h squared. So I automatically notice that I have h that's common, and 10 can be divided by 5, so I have 5h outside. leaving me now with 2x plus h all divided by h. Now with this being done, this h would cancel that there, leaving me with h as it approaches 0, 5 times 2x plus h. And this is going to be equal to the limit of as h approaches 0 of 10x plus 5h. And like I said earlier on, you're going to substitute whenever you reach this stage in general, when you always have your cancellations done, you would always have to substitute 0 wherever you see that h. Or how you'd always say it, wherever you see h, you put 0 in. So I would have 10x plus 5 times 0, which is going to give me 10x. Now, this particular part here, some persons would, or this is what you would normally see persons do at this step here. They would say, okay, I would just have, let me use a different color. Yeah, some persons would look here and say, okay, h is common. I know my answer needs to be 10x, so I'm going to put 10x plus 5h being divided by h. These two cancel out, give me 10x plus 5h, which is equal to 10x plus 5 times 0, which is 10x. Now again, it comes down to how countable you are, but if you are generally just from algebra, you should keep practicing the concepts that you learn, even though this here is going to be a little bit longer to complete. Next is 3x squared minus 2x. So what we have here, f of x is equal to 3x squared minus 2x. Let me just switch back to black. Alright, I'm going to put this as pencil for now because of all the writing that I'll have to do. So dy over dx is equal to 236. I have 1x remaining minus 2. So that's my final answer. Before I do that, let me just indicate that here. Good. Alright. Now, this is why I said I wouldn't be writing by the formula, because of the length. If you notice, in this case, we have x squared and x, and then just the 2x that's here. You have to write it the x plus h for each occurrence of an x. So, dy over dx is equal to the limit as h approaches 0 of 3 times x plus h squared minus 2x plus h minus, again, make sure you put this in a bracket, 3x squared minus 2x close bracket. And this is all being divided by h. For you, you should probably write your formulas out so you can actually remember it. So let me just work this here out now. H tends to 0. So I have 3 of x squared plus 2hx plus h squared minus 2x minus 2h minus 3x squared plus 2x. Alright, things seems to be working out as they should right now. I need to adjust my sitting posture. I'm slanting when I'm writing. Alright, so this is the limit as h approaches 0 of 3x squared plus 6hx plus 3h squared minus 2x minus 2h minus 3x squared plus 2x. Yeah, this is why first principles gives persons quite a hard time. It's all the writing, and you need to pay attention to your signs. Alright, so you look at the cancellations now. So this 2x is going to cancel this negative. Let me just write this negative so you can see it properly. The minus 3x squared is going to take care of that positive 3x squared. Like you always, I said before, whatever your f of x is, there's something inside of your expansion that's going to cancel it out. You just need to look for it and ensure, and it's one of your ways to know that you're actually going on the right path. So next here now, the limit as h tends to 0, I have 6hx plus 3h squared minus 2h. And this is all being divided by h. You'd always need, well, this is a trick that I could probably show you. Whenever I have something remaining, I would put an asterisk over it as an indication that, you know what, these are what I actually need to write down as I continue my problem. Alright, so here now, the limit as h tends to 0. Looking at my numerator, I have what's common is h, leaving me with 6x plus 3h minus 2, which is all being divided by h. These cancel, leaving me with limit as h tends to 0 of 6x plus 3h minus 2. So this is equal to 6x plus 3 times 0 minus 2, which is 6x minus 2. This is my dy dx. So in simple indications, when you see, you can cancel out the denominator with something from the numerator in terms of after you factorize. That's the beginning of telling you, okay, I now need to substitute h into whatever I have in order to actually complete it. Alright, so three more questions. Wow. So it's x squared plus 6x plus 9. Alright. So f of x is equal to x squared plus x squared plus 6x minus 9. So I know after I finish working this from the power rule, I'll have 2x plus 6. Yeah, this is going to be a little bit of a lengthy problem. So my dy over dx is equal to the limit as h, I'm going to say another terminology, tends to, same as saying approaches 0, tends to 0 of x plus h squared. So you notice I just write x plus h squared because there's no number that's working with the x squared, plus 6x plus h. Yes, even though I'm a math major, I prefer not to use the math terminology when I actually work problems out, because I know these videos are going to work better for persons that are not math majors. So as I'm actually just completing this out, the reason why I actually decided to start sharing these videos is because some of my past students are in this calculus class, and also I have a fellow colleague at work in here as well. So I don't know exactly how well they're favoring in terms of working out problems, but we all know that calculus has a long history of making persons very fearful. So I'm just ensuring that this doesn't stress them out too much. 6x plus 6h minus 9. Ah shoot, I'm slanted. I need to sit properly. Alright, so yeah, there's a thing with working with these tablets is based on how you actually sit. That's how you're going to kind of write. But I just need to adjust myself properly to ensure that I don't tilt so much. Alright, so what I have here is x squared plus 2hx plus h squared plus 6x plus 6h minus 9. So again, you see the power of this bracket helps out with seeing what's going to happen. I have minus x squared minus 6x plus 9. This is all being divided by h. So go ahead and cancel. Plus 9, get rid of minus 9. Minus 6x takes care of this positive 6x. Minus x squared takes care of the front x squared. So asterisk, asterisk, asterisk. So my dy over dx is equal to the limit as h tends to 0 of 2hx plus h squared plus 6h. And this is all being divided by h. So dy upon dx, limit as h tends to 0. What's common in the numerator? H, leaving me with 2x plus h plus 6, which is being divided by h. So this is equal to h tends to 0 of 2x plus h plus 6, which is going to be equal to 2x plus 0 plus 6, which tells me that my dy upon dx is equal to 2x plus 6. Alright, so, alright, yeah. Alright, now this one is going to be a little bit lengthy, so I'm just going to take a short break and then I'm going to Okay, I am back. Yeah, sometimes you just take a break from all the maths, and I know that this here is going to be, it's going to be a long one. Yes, of course I did work this out before, but again, it requires a lot of thought processes to be completed. Sorry about that. Alright, so f of x is equal to 2x squared minus 1 over x. Alright, so f of x squared is equal to, what am I doing? F of x is equal to 2x squared minus 1 over x. So at the end of this, my dy upon dx is equal to 4x. Now, if you have worked any of the 1 over x problems, you know to yourself that it's going to be 1 over x squared. However, the answer is generally negative. If you're given it to be a negative 1 over x, then the sign is going to change to positive. If the sign is positive, then it's going to be negative. That's a quick rule when it comes to working that problem out. Alright, so let's start on this adventure. Alright, dy upon dx is equal to, as the limit as h approaches 0, 2 of, alright, x plus h squared. I will have to work this slow. 1 over x plus h minus 2x squared minus 1 over x. Again, these fractional problems, I tell you, as power rule, it's easy to work with them because you just flip up and, you know, do the damn thing. But when you see you have to work it out in the first principles, there's so much to pay attention to. Alright, so I'll just go ahead and just write this out. I'm not going to expand because I know what it's going to be. You can actually have that done. So this is going to give me 2x squared plus 4hx plus 2h squared minus 1 over x plus h minus 2x squared plus 1 over x. This is all being divided by h. So 2x squared gone, 2x squared, there is gone. So I left with 4hx, 2h squared minus 1 over x, h, and 1 over x. So you automatically notice that the 1 over x is still there, and you can't actually solve until that there is no longer part of the question. So this is why I said this is going to be long. Alright, dy over dx, limit h tends to 0 of 4hx plus 2h squared minus 1 over xh, x plus h, plus 1 over x, all being divided by h. Alright, so this is where I do things the way that I am more comfortable. You see this that look like headache? I'm gonna work that and then I'm gonna put it with this. So just bear with me a moment here. So I have minus 1 over x plus h plus 1 over x. This is just my way of ensuring that I focus on all the small details. I always take things apart and I put them back together. So this is going to be times x, and this is going to be times x plus h. Meaning that when I look at what I have here at my LCM, I'm going to say, okay, the x and the x plus h and x plus h will go, leaving me with just the minus x, and then the x will go, leaving me with x plus h, x, this, and this will cancel, leaving me with h over, I'm going to expand this here out now for simplicity's sake, the x squared plus hx. So if you notice here, I identified that it's going to be a positive h divided by x squared plus x. h divided by x squared plus hx, Now I'm going to write everything together. So I have 4hx, 2h squared. So writing it all together, so I'm going to put all together. The limit as h tends to 0. Again, it's still going to look a little bit funky, but at least it's workable. For me at least. 4hx, 4hx plus, what do I have up here now? 2h squared plus 2h squared plus h over x squared plus hx. Yes, I know it still looks a little bit jumbled, but again, like I said, it's workable. So this is the approach that I used to complete it, and maybe someone else would show you a working that's probably less complicated than the way that I sometimes choose to do stuff. So factoring out, I have h, we've made 4x plus 2h plus, remember the h in the numerator is what I'll be factoring out, so I'll have 1 over x squared plus hx, and this is all being divided by h. This gets cancelled out, so what I'm left with now, the limit as h tends to 0 of 4x plus 2h plus 1 over x squared hx. Again, if anyone else probably had some easier steps, I would happily look at them when you share them in the Google Classroom. So let me just work on substituting now. So 4x plus 2 times 0 plus 1 over x squared plus 0 closing bracket x. We know this is going to give me 0. This is going to give me 0 as well. So dy over dx is equal to 4x plus 1 over x squared. I know this is, again, I'll apologize for the lengthiness of this particular component. And again, if anyone has some shorter methods to help out the non-math specialists, then please share it with them so that they don't have to go through this, what's the word I'm looking for? This gauntlet. Alright, final one, f of x is equal to 10. Alright, so something to already focus on, right? I'll need to write the formula out, so just allow me a moment here to write this out. Dy dx is equal to the limit as h tends to 0 of f of x plus h minus f of x, all being divided by h. Now, the issue that most persons will immediately jump into is saying, what is x plus h? Now, let's just backstep. I need to go all the way to the top. Alright, I'm at the top. Alright, not there. Yes, here. Let's use this as our base of understanding. F of x is equal to 3x. For this particular problem that's here, you notice that when we actually worked it out, this f of x is always written back there. But look at the interaction that happens here. Pay very keen attention to that. The 3 goes in front, and then the x is considered in the bracket itself. So now let's go all the way down to, I don't think I always have these pages set to 30, so let me just go back up, here. So I hope that in tutorials I personally could actually have this answered for myself, but I am of the belief that when we are doing the derivative, we say that this is equal to the constant. Or sorry, when this is a constant, we know that the dy over dx is equal to 0. Now, using that same understanding, is this also equal to the constant? I use that understanding to actually work this out. So what I would say happens next, using this here, f of x is going to be minus 10, and the f of x plus h is also 10.